There we are. Good morning, good afternoon, good evening to people around the world. This is your host, Martin Hubel, host of the DB2Night Show. Today we have a great LUW show, number 223. Who knew we could run this show that long? I've got a very special guest with me today, Toby Haynes, Technical Manager of pureScale in the IBM Toronto lab. How are you doing, Tony?
I'm doing very well, thank you.
You can dress me up, you can't take me anywhere. And we are, for better or for worse, we're both sharing the same weather, seeing as we're about 10 minutes apart if we take the fast road over to the lab from where the night show has its headquarters here in beautiful suburban Toronto. And so we're underway, and we'll be carrying on now. Toby, give me a sound check. Please say something again.
Good morning, folks.
There you go. Thanks. I turned my speaker down too far. Sometimes I wear a headset, but as my little dog gets older, he is and at this time of year, he's far less concerned with squirrels than he used to be. So I'm taking a risk here and just doing this open air to let my ears flap in the breeze. Oh, sorry, that's just the furnace fan being on. Okay, here's our standard social page. This is your show. There's your Twitter, LinkedIn group, and now we have our replays available on YouTube. So if you don't want to, if you've got a good internet connection and don't want to download anything, you can do that. I'm hoping that Toby will share his slides with us at the end. And
I will indeed. Yes, I'll make them available as PDF. So
we'll put those the slides up on the replay blog as well. Some people just prefer to read as opposed to having to listen. That's fine too. Here's our standard disclaimer with all of the things basically saying we're recording the show and everybody gets to be respectful, and we are also respectful of trademarks and copyrights and that sort of thing. And as such, that's what's happening. And there's our standard agenda. We have some quick announcements, the studio audience polls. I don't think I set any up, but I'll have to go through and see if we've got those done. If not, I'll just set up one at the end which will ask you whether or not you learned anything today, and that's the standard thing. I'm noticing I have 0 polls set up, so there you go. That's me paying attention again. I'm so good at that. This week got away from me though. I've been scheduling and trying to set up the Central Canada DB2 user group in Toronto, and there's been a lot going on, particularly in relation to the new COVID-19 or coronavirus, and that's sort of putting the screws to an awful lot of things that are going on in the world. If you're a traveler at all, airports are kind of a nervous place to be. Cruise ships are really having issues. I feel for them, seeing as my dear wife and I, we just came back from a trip in January around the Southern Caribbean on Princess cruises, which we enjoyed immensely, just to find that they're having all sorts of problems over in Asia, also Holland America as well, which we enjoyed traveling with. And we feel for them, and we're hoping they can get that sorted soon. But the IBM is rethinking their major conference in San Francisco. They're rebirthing that conference as a virtual conference only so that people don't have to travel. But having said that, we're still set up here to run our conference, but it's caused an awful lot of reworking for our executive up here. Okay, our show's coming up. April 3rd is Carrie Romanoff of the IBM Toronto lab giving us an update. I've been after Carrie to give me your topic, and I know she's working on it because she's mentioned that to me several times, so I should have something within the next week to put up on the website, and I'll get that show available for registration shortly. May 1st is the show after that. I have a speaker in mind. I just need to reach out to him and see if he's going to be available. And I've programmed myself on June the 5th to end our LUW edition of a presentation which matches a blog entry I did on the IBM community site called Data Pioneer. And you can look at that article and tune in to see what you think of that presentation. I've done some work with what you'd call startup companies, and the idea of introducing a DBA role into a bunch of developers who are using DB2, and how do you introduce integrity or ways of ensuring integrity into new organizations and even departments within large organizations. On the DB2 on Z side, we have Julian Stuhler in 2 weeks on DevOps for DBAs. And then we have our famous annual All About IDUG show on April the 17th. On May 15th, we got Mariella Wyrock, an IBM Distinguished Engineer from the Silicon Valley Lab. And we finish off with Dave Belkey on June the 19th. So things are looking pretty good there, and we'll finish off the year in grand style. And as always, our DBI software is the founding sponsor of the DB2Night Show, and we invite you, if you're interested in having your DB2 LUW environment run faster, with greater efficiency, and also to ensure that you have great service levels, you might consider watching a demo of their product at the following site, DBI software, on their demo link. It's readily available from their homepage. Winner of our last show's gift card from Amazon. Remember, watching the DB2Night Show can be rewarding if you log in. We checked our logs to see who's there, and we randomly choose a winner. Doug Platts of Cigna is this week's or last week's winner, or this week's winner from last week's show. There's our sponsors, DBI and myself, Martin Hubel Consulting. And once again, I put up the overview screen of the new DBI version coming out. You can have a quick look at that, and you'll see more if you watch their demo. I also put up this week a picture of my silent partner here that helps me run the Z show as well as the LUW show, actually, should say both. A different picture or two of Charlie. The reason for putting this up is he was very, very sick last week, and while I was teaching a class from home, I was teaching a DBA class, he was actually yelping and in great pain. He had, we think, a couple of, well, we know he had 3 seizures. We thought we'd be losing him. He turns, in 2 weeks' time, he'll be turning 15 years old. So he's still a cute guy, taking up my side of the couch, or what I thought was my side of the couch, and doing what he does. He's still with us, and actually he's back to his old self, so we're kind of relieved about that. And as I said, we'll be going over the polls for today. Just moving on, and I'll be turning things over to Toby. Toby, I'll make you the presenter, and you can take it away. As always, we have a Q&A tool that we use, and you'll find that available. There's a little menu that comes with GoToWebinar. Please type your questions in there, and at an appropriate moment, I'll break in and ask Toby your question, and we'll respond and keep the show interactive in that way. So Toby, please take it away, and I'll be here if you need me.
Okay, so I should give a quick sort of background of myself, I think. I've been with IBM since April 1999, so I joined as part of this core DB2 engine team doing development for about 8 years at the time. So I saw the arrival of the DRDA communication streams and was a part of that changeover from the old DB2RA. So if you go back with DB2 to that genre, I think that would been DB2 version 8. And then I transferred from being a full-time developer to taking a role on the performance team under Bernie Schieffer, who probably is a name who's familiar to people who've been with DB2 for a while. And I was managed by Steve Rees, which I'm sure is a name which is familiar to most of you. So I stayed as a performance analyst for DB2 for the best part of a decade, working almost exclusively on what was originally Project Coral and then was debuted as DB2 pureScale. So I've been along with the pureScale developments really from the time it transitioned from being just a research project to being something which was being productized. So I've seen a lot with this product. About a year and a half ago, I got the opportunity to step up and manage the pureScale development team. And that's been a fantastic opportunity to sort of get to know the developers and work with them on driving this product forward. I've also had a lot of contact with the support team who work tirelessly to keep customers' systems in good shape, help them understand what's going on. pureScale is a fairly complex software stack, so there's many aspects to sort of understand and monitor and grow from, and that's sort of a good place to start. So as of June 2019, we debuted 11.5 GA, and let's get started on this. Now, standard IBM legalese, so I'm just going to quickly move through these two. It says what you would expect IBM to say. Okay, so, right. So pureScale's an integral part of IBM's high availability systems, and we've seen a lot of growth over the last few years in the number of customers who are interested in pureScale, and the sorts of customers who are coming to us cover many different industries. So we've got core banking systems, there's governments, healthcare, industrial sectors. We've seen a lot of feature requests, and now we have an open ideas platform on AHA where you can go and ask for features you feel are important, and also see what other customers are asking for as well. We constantly look for ways to sort of address the sort of key needs of customers. So 11.5 is building on a decade of development and presence in customers' hands, and we're looking for really to beef up on sort of core strengths. So in the 11.5 series, we really targeted 4 core areas. Security is, you can't have a highly available database and it's not secure. You have to be secure, and security comes in lots of different areas. So I'll go into more detail on each of these topics. Consistency is another key thing. Customers who are considering pureScale, they want to move to pureScale. They don't want surprises. They want their system, which was running as an HADR pair or a standalone host. When they go to pureScale, they want it to work the same way. They don't want to have to deal with too many complexities or too many changes in behavior. So consistency is really important when it comes to pureScale. Robustness. pureScale is supposed to be nearly continuously available, and that's the goal here. And we have customers who run successfully in that mode, and that's a huge testament to the work of a huge number of people. But this is software. There's bugs, there's problems, hardware dies, and so there's always areas where we can improve our robustness, and so we're always looking to step up and go further. And no modern database survives if it doesn't perform. So pureScale has its own set of performance characteristics. We're always looking to make sure that the transition from other products, including sort of our own DB2 configurations to pureScale, are as seamless as possible. And anytime we can step the performance up and make the product go faster, those are always good things to have. Right. So let's get started with security. Security is not a one thing. It's about a process, and it's about addressing as many areas as possible. So security starts at the application layer. It extends through the network. It's about authorizations and permissions. Encryption's a key part for an awful lot of customers these days. So defense in depth is the key piece here. So we've got a very large code base for DB2 LUW. And with the best efforts of the developers, it's always good to have more tooling. So we use AppScan, which is a static code analysis system that's been used heavily through the 11.5 development phase. And it's picked up a number of areas where we've been able to harden the code before anybody's been aware that there's been a problem. So these things allow us to be very proactive and catch problems before anyone gets the code. So that's been great. We've also gone for encrypting connections through SSH as an encrypted database. But when it comes to network security, most customers are thinking about firewalls. And in the 11.1 stream, if you try to set a firewall up against a pureScale instance, there was quirks, shall we say. Now I'm going to get into precisely what we've done later. So I'm going to address the four sort of pillars here, and then we'll get into details. I haven't forgotten about security. So moving on to consistency. So yes, consistency is about being able to just step onto a pureScale platform and take your application over and have it just work. But any database has a certain amount of configuration, a certain amount of steps that have to go through to install it and get it up and running. So we're trying to reduce the amount of manual setup, and we're trying to be more consistent in every way we can. PureScale promises functional compatibility between all of the DB2 LUW options, but there are sort of interesting behavior changes. And so anywhere we can improve the way or make more consistent the behavior of DB2 PureScale when you move between standalone, HADR, and PureScale configurations, that's always good for everybody. So robustness. As we've gone through the PureScale journey, starting in version 9.8, as customers, as our own testing has worked through the system, as our customers have worked through the system, we find new corner cases, new areas where we want to make sure that we are monitoring correctly. And so all the way through the PureScale journey, we've built more awareness into the cluster. And in 11.5, we've closed one of the holes which was left open, which is now we configure a configuration of the public Ethernet devices. So if they go down, you don't have to do anything extra. The automation will kick in and handle the failure. You'll get it reported to you through the cluster alert system. So that helps anywhere. Another area which has been painful for PureScale customers is you can put a member or a host into maintenance mode in PureScale to do operating system upgrades. So if you upgrade the kernel on a Linux system, you reboot the system, and if you haven't rebuilt the Spectrum Scale modules, that node's not going to be able to mount its file systems. And as PureScale is built solidly on Spectrum Scale, that's a problem. In the 11.5 release, those kernel modules are automatically built for every kernel upgrade you do. Again, this is about making things more seamless, making it less of a sort of list of things you have to check, that the system just works after sort of standard operations completed. We've updated the software stack pretty much across the board. So PureScale is the DB2 core engine. And then at the file system level, we have this IBM Spectrum Scale suite. Then our automation platform is Tivoli System Automation. That's handling the awareness of the system and the actions which are carried out in response to the various monitors which are built into Spectrum Scale. And then we have IBM's Reliable Scalable Cluster Technologies, often referred to as RSCT, and that is the network layer. It knows about the topology of the cluster. It's monitoring the health of the networking between the various parts of the system. So all of that's been updated. And every time we go to a new release, we're always looking to add more testing. We run 10,000, 11,000 functional tests on the vast majority of builds we do in development. There are months of code base hardening through our stress test team. We have a performance team who works tirelessly to make sure that we don't step backwards. We're adding a lot of code to DB2 generally. Adding code can increase path length through various parts of the product, and we can't have that impacting customers' existing workloads. So we're constantly looking at all of these areas to make sure that we are keeping things on an even keel. Now, I mentioned that pureScale's been around for a decade, and I think it's important to think about how the sort of hardware side has changed in that time. When I look back at what was the sort of state of the art in 2008, 2009, yes, that's about right, sort of Power 6, fully maxed out Power 6 box, 32 sockets, 2 cores per socket, you get up to about 128 logical cores. You look at Power 9, you're looking at 1,500 logical cores. So parallelism is the sort of driving force in computing power these days. And so we have to be able to make use of that parallelism if we're going to be providing the best solution to customers, to users. And we've made some significant steps forward in making sure that DB2 pureScale specifically can use that increased parallelism we see on the hardware platforms. Right, so let's get into the security changes. So firewalls, I don't think anybody runs a laptop these days without a firewall. I hopefully nobody runs any system at home without a firewall. It's the standard. And yet when we come to the data centers, yes, there's firewalls getting into data centers, but customers are looking to deploy firewalls on a per host or per LPAR basis these days. That's understandable. The defense in depth for security makes lots and lots of sense. So on Linux, the sort of popular solutions are IP tables, and there's NF tables, I believe, coming out soon on RHEL. On AX, it's IP security, can be used to filter network traffic. And that's SMITI IPsec4 command, and there's genfilter as well, I think, as well. And host-based firewalls are there to limit access. You don't want to allow an attacker to be able to just casually scan through all of your ports and find out what's going on. And host-based firewalls attempt to limit access to ports, hosts, and related connections. Most firewalls these days are stateful. So we want to make sure that pureScale can work in that environment. And so in 11.1, we had a design for a lot of the networking where we would end up using what were essentially random ports for a lot of operations. And this would be true for install, upgrade, and sort of key parts of sort of regular sort of communication between members. And this makes it difficult to design a firewall if you basically have all of the ports above 1024 open. And if we don't provide a way to sort of understand those patterns, you can't write a set of firewall rules to work. And yes, if you are configuring a system, yes, there's going to be ports which you know about. Service name port, for example, would be the key requirement, and it's obvious where you want to go with that. But if you put your firewall in and you've opened the service name port and you try and run pureScale, what tends to happen is that sooner or later your firewall blocks some network access. And when you've blocked a network connection, sooner or later it'll probably time out, you'll get a failure. It may not be obvious why the command has not worked. And so it's, at the end of the day, it's frustrating and it's sort of time wasted. So we wanted a one configuration for this. And we wanted to also to make sure that we didn't end up bottlenecking. If we just opened one more port for the rest of the operations, we would have ended up with some terrible contention on that port. So in 11.5, users can specify a port range through a DB2 registry variable. So using the DB2 set command, and this can be set from before install and left all the way through deployment and maintenance. Now, at the moment, we recommend having a fairly wide range of ports. So our testing was done with 2,000 ports, which is still a very large number. We think you can probably get down to about 200 ports, but we haven't. Every customer's workload is different. Everyone's network activity is different. So there may be a certain amount of try it and see. Any sort of any contention will quickly be resolved because we keep searching for ports to look for. But like I say, we're currently recommending 2,000 ports, which is just gets you down to about 3% of the available port range. That's a sort of step in the right direction, and hopefully customers with good testing can probably get quite a lot lower than that. And so this port range affects the ports on the target system. So if you're writing firewall rules, that's what you need to be thinking of. So the source ports are still unconstrained, but the target ports are limited to the specified range. So the DB2 core engine is not the only part of the system here which is making network connections between the various hosts in the system. So the TSA and RSCT, they have their own ports, they're configured, they're listed in etc. services, so you can find those. Spectrum Scale has its own implementation for limiting the port range that it will use to communicate between hosts. So if you set this registry variable and you've installed Spectrum Scale as part of your DB2 pureScale install, then this solution manages the Spectrum Scale part as well. So part of the port range you specified is set aside for Spectrum Scale specifically. So that, again, keeps things neater. If you're wondering what the key ports are for TSA and RSCT, I think they are 12.347 and 12.348, and I think both of those are UDP ports. The other ports which are usually critical are SSH, but hopefully most people have got that already configured as part of their firewall. And those TSA and RSCT ports are being used for network heartbeating more than anything else. If you came to pureScale and you already had Spectrum Scale installed on your system, then you've probably already tackled this before. So in Spectrum Scale, under the configuration, which you change with mmchconfig, the configuration parameter is TS port range, and you can verify whether you've set that using mmlsconfig, see what's there. Right, so that now provides a fairly straightforward way to get a firewall up and running on a host in a pureScale cluster. So let's move on to consistency. So this is a classic case of how evolving features sometimes interact in ways you didn't anticipate when you designed them. So we had a customer who came to us and said, look, our tables, they're not reclaiming their free space properly. And our table's growing very, very large. We can see there's a lot of free pages in it. And we don't understand why on this pureScale cluster, why these free pages are not getting reused. And we sat down and we worked through their data and we agreed with them that this was clearly a problem. And the analysis continued, and we realized that their workload was making use of member subsets. And so they had one workload which was doing insert work against a small number of members in the pureScale cluster. Now, member subsets came along as a way to sort of control where a particular application, a given workload, was connecting to members in the pureScale cluster. So You can say, okay, I want these 2 members in my 4-member cluster to handle workload A, and if one of those members goes down, it'll be handled in a sort of consistent way, and we will make sure you have capacity to work. And when the members are all back in your subset, then the connections will flow back, and you continue with business as usual. There were previous methods which were sort of client affinities, and they tended to have the characteristic that if you set a client affinity for a workload, if you say okay, the first host in the system was your client affinity for your first workload, if you took that host out for maintenance, the workload would then flow over the rest of your cluster, which wasn't necessarily what customers wanted. So member subsets, great feature, very useful for if you've got a very large pureScale cluster and you want to limit which workloads are working against which members. It's a great feature. And it came along in, I think, 10.1. Anyway, so when we looked back into our free page reuse code, it wasn't designed with member subsets. It predated the member subset work. So we looked at the customer's workload. So one workload's working, it's doing inserts against 2 members in their cluster. And they had another workload which was doing sort of more sort of query-based and sort of cleanup type operations using a completely different set of members in the pureScale cluster. And this got us thinking. So we observed that the free pages in the table were not being reused, and this had the impact that the few table scans they were doing on these tables, who I never like to see table scans in a database, but there were table scans taking a lot longer than needed, and we got an RFE from the customer to tidy up this behavior. So let me walk through what was going on here. So we had inserts on a set of members, and so every now and again, pages get deleted, add more data, delete some more rows. I know we should really see those inserts going into the first free space, but it's not. And so the table just keeps growing, and it gets worse and worse. So we looked at the design, and each member was tracking its own free space. So the inserts, they're just inserting. They don't know the free space is being created by other members in the cluster. Now, at any point, if some operation on that member doing inserts had started to delete rows out of the table, then we would have started to go and fill in the sort of blank spaces, but this customer's workload wasn't doing that. And obviously, this is not desirable behavior. Whoop, too far. Yeah, so member subsets came in v11.5. And yeah, very popular with customers, particularly for separating off batch workloads and putting OLTP somewhere else, then maybe analytic reports and somewhere else. So our solution was we really need to make the availability of free space known across the cluster. And in a pureScale configuration, the obvious place is the cluster caching facility, or the CF. It's there, it's the sort of central arbitrator for pages and caches, and this is perfect use of it. So now the free space for each table is managed at the CF. And this is the new default behavior in 11.5. Should you want the old behavior back, and I can't actually think why you would want the old behavior back, then we did provide a registry variable so you can disable the new code. But no one's asked us for this one yet. Okay, so this is sort of just to round out that thought. This is a case of sort of features evolving the way pureScale can be used, and we look deep into our designs. Whenever a customer spots something which is not working to their specifications, to their expectations, and we don't think there's many of these left, but we're really pleased to have this now properly resolved. Currently committed. So cursor isolation levels. are a way of sort of seeing which data you want to sort of see in the database. And cursor stability isolation can lead to lock timeouts and deadlocks, and that can be that could slow down your transactions, cause deadlocks. If you're that's generally not good behavior. Currently committed semantics reduces the amount of lock weight because readers don't wait for writers to release row locks, and you get data based on the data prior to the start of the write. And this has been around since v9.7, so that predates pureScale. When pureScale came along in 9.8, it didn't support currently committed, and in 11.1, currently committed semantics only apply to the lock conflicts on the given member. So if an application is spanning more than one member, which is the default, workload balancing is going to generally spread your workload out unless you're using client affinity or member subsets with just one member, you're not getting any benefit from currently committed semantics. And so your lock weights are higher than if currently committed was running in a cluster-wide fashion. So in 11.5, we fixed this. So now the last committed version of the row is retrieved from the remote member, and we get the data not from disk or buffer pools. We read it out of the log buffer, which is held in memory, so there's no extra disk I/O. This feature doesn't then increase the load on your storage. And the result is improved transactional performance because you've got less lock weight. Now, if your current application in 11.1 is showing high lock weights in pureScale with currently committed enabled previously, you may see benefit. And the amount of benefit is hard to quantify on a general level. We ran some sort of generic OLTP workloads, and even there we got a sort of 1 or 2% improvement in performance, which in a product as mature as DB2 is, it's actually a surprisingly good result. I'm sure there's workloads out there which will benefit significantly more than that from this improvement. Moving on to robustness. So GDPC is the geographically dispersed pureScale cluster. So this is the sort of ultimate high availability solution. This is where you have 2 data centers across town. We generally say that these data centers shouldn't be more than about 30 kilometers apart, because the further apart they are, the longer it takes to communicate between the 2 pieces. So GDPC, it's a complicated setup for pureScale. You've got 2 data centers, 2 SANs replicating. You've got a lot of networking, which has to be done absolutely correctly, 2 switches at each site. So there's already a lot of complexity in the hardware setup, but also setting up a GDPC cluster on the software side had a lot of manual steps. So the goal here was to try and reduce the number of manual steps, the number of commands you had to type in to get your GDPC configuration up and running. Second goal is to make sure that the CF resource setup is always correct. If we can automate it, then hopefully we get it right every time. And so we're trying to get to the point where we automatically create public Ethernet condition response pairs for every operation. So those condition response pairs are the piece which says, is my network interface up and running? Is it in good health? And if it goes down, the rest of the automation needs to kick in and to take appropriate actions to make sure that the database continues to be available. So we put this together, and there's a performance benefit as well. So if you reboot a cluster or you have a surprise power outage, the pureScale system fails over 8% faster now. So when I talk about the number of sort of manual steps and commands needed to get this set up and running, In GDPC, after a typical install, there were 33 commands to type. And yes, it's step by step, and you can mostly cut and paste it in, but still not great. And after every maintenance operation, so you've taken a member out for, say, an operating system security fix, or maybe you've done a rolling upgrade, there are another 6 commands to run. In 11.5, they're all gone. That's all good news. Anytime we can reduce the number of things that have to be done, it makes the playbooks easier, shorter. It's just less things to go wrong. Properly configured every time. Okay. So Spectrum Scale. Spectrum Scale is the only file system that pureScale supports. We need a cluster file system which has characteristics for extremely high availability, minimal to no contention. Spectrum Scale fits the bill. And in 11.5, we've shipped with the Spectrum Scale 5 series for the first time. So that major new version brings us automatic kernel compilation for Linux. That's enabled by default. And so, yes, your operating system upgrades on Linux are now handled automatically. That's not the only improvement which comes with Spectrum Scale version 5. We have, in Spectrum Scale, you can add new storage into your existing file systems. You can define an NSD in Spectrum Scale and add it to an existing file system. When you add that NSD onto your file system, at first there's no data assigned to it. And most customers want to balance out the data across the various drives and devices they have underneath the file system. So being able to quickly bring that file system into a properly balanced state across all the devices is really important. And so there are significant improvements in file system rebalancing in version 5. We've seen performance improvements in terms of concurrency on small shared directories. And there are a number of I/O performance improvements as well. So block size in Spectrum Scale is 1 megabyte. Obviously, most of the database activity is 4K writes. So performance improvements in small sub-block sizes has had some I/O performance improvements. Precisely what you'll see is going to be a question from which changes from workload to workload. Now we've made some configuration changes, moving up to the new version. Some of these didn't exist before. We've used the cipher list configuration now does basically a check that the host at the far end is cryptographically signed. So it makes sure that we are talking to the right host and we haven't been spoofed into talking to somebody else. Auto build GPL is the option which controls the kernel module compilation. Now, when I get down to worker threads, in Spectrum Scale, there are a number of ways that previous versions of Spectrum Scale allowed you to configure how the how the processes would map to I/O. Worker threads, there was worker 1 threads, worker 3 threads, which you could configure. If you support engagement, sometimes people would get these bumped up. They had certain ratios which had to be maintained, and if you didn't maintain them, you might run into uncharted territory. So I'm pleased to see that we now have just one parameter configure. Over the life of DB2 pureScale, I think we started off with worker 1 threads at about 512, and we moved up to 2048. So when you look at Spectrum Scale 5 and you see we're back to worker threads 512, you might think, oh, hang on, going backwards. No, this new value is actually pretty consistent with the worker 1 threads being 2048. So we're sort of, again, simplified configuration is a benefit here. Another area where we've gained experience over the years, particularly with performance on Spectrum Scale, this parameter max files to cache. If you think about a database, you think, hang on, the database has got maybe, I don't know, 50, 100 containers, maybe a few more than that. There's the DB2 dialog files, it's log files. 1,000 files to cache sounds like it should be more than enough. it turns out that this max files to cache configuration parameter actually also helps cache accesses within the large containers as well. So this configuration parameter has been bumped up through various releases. We're at 15,000 right now. And it's safe to put this higher if you need to, but out of the box, this works for almost all customers. And only the customers who are pushing sort of really substantial workloads with sort of 0.5 terabyte of RAM per member need to go much higher than this. Anyway, so that's where we've gone with Spectrum Scale. Performance, topic near and dear to my heart. So moving from a standalone host to pureScale, load performance does tend to drop. The reasons for that are complicated, and they break down into a number of different areas. But one of the key areas is that load requires the buffer pool to be flushed or purged before we start the load. Now, we've put in optimizations over the years for the standalone, ESE or Enterprise Standard Edition. Those optimizations group up a lot of the purging so we can do it more quickly. But in earlier versions of pureScale up to 11.1, for each sort of type of thing we needed to purge, and this would be per index, log columns were grouped together. And so there was an opportunity to spend a lot of time doing a lot of these purges, and it basically made the sort of startup of load extremely slow. And in pureScale, we need to reach out to each member and get this purge managed across all of the parts of the cluster. And so we need to do a remote procedure call to each member. So the obvious low-hanging fruit here is to actually start by grouping up the flush purge for the partitions, the indexes, the log columns, and make sure we do that in one shot. And we got a significant step forward. It's 2 times faster. Now, I'm not totally happy with the load performance still. I think we can go further. There are various threads we can chase with our buffer pool team. We've got some more complex optimizations that we're investigating, and that should allow us to sort of look for specific ranges inside the buffer pools. But this is where we are today. We've gone to 2 times faster, at least in the tests we've done. So, steps forward. Multiple XIs. XI stands for cross-invalidate. And so, just to sort of give folks who may not be familiar with pureScale some information here, cross-invalidation is the process that basically makes sure that the cluster has a consistent view of the data in the database. So if one member is making a change to a page, it will basically upload its changed page to the CF. We call the process write and register. So I think Dale touched on that, or it's certainly been touched on in previous DB2Night shows. When a change is made on a given member, other members in the cluster may have copies of the same buffer pool page. We want to make sure that they know that they shouldn't use that, that copy that they're holding in their cache is not current anymore. So cross-invalidation is the way we make sure that all the parts of the cluster know that a given page that they held in their cache is not valid anymore. Now, in 11.1, we realized we were getting bottlenecks. That you could end up with a lot of cross-invalidate requests, totally serialized on a single connection. And the more changes you have being driven into the database, the more cross-invalidate requests you have flying around the system. This is particularly painful for pureScale running on sort of standard Ethernet without the benefits of RDMA, remote direct memory access. And so we delivered that in 11.1 mod 3 fixback 3. And that gave significant boost for write-heavy workloads on pureScale for sort of standard Ethernet. When we wanted to do the same for RDMA. So in 11.5, we have support for both Rocky and InfiniBand improvements. And again, we saw performance benefits for systems where we didn't really think that there was going to be any benefit. So as just a standard OLTP workload, benefited by 1 to 2%. We've made 2 XI connections the default in 11.5, so this can be stepped up. But the benefits here are more likely to be significant for our geographically dispersed pureScale clusters. So for those clusters which do use RDMA over converged Ethernet or RoCE, the benefits may be quite significant. And it'll really depend on just how much traffic there was changing pages around the 2 data centers as to just how much benefit there will be. And if you think about the speed of light, I really wish the speed of light was faster, but our rule of thumb is that for every kilometer of distance between the 2 data centers, it's about 5 microseconds, 5 to 10 microseconds. So it's that can add significantly to the amount of time it takes to get one of these cleared out, and therefore being able to do them in parallel has a really significant benefit. I mentioned earlier that modern processors have really embraced parallelism. Moore's law of sort of no longer being driven by increases in clock speed, being driven by increases in parallelism. So since version 9.8, pureScale supported up to 31 worker threads. And that was fine when you had each member was running maybe 60 to 80 logical cores, and 4 members would pretty much saturate that amount of worker threads on the CF. And all of that's controlled by the CF num workers DBM configuration. In 11.5, we've moved that number up to 96 worker threads. That sort of really helps sort of bump up the capabilities of systems. We've done some performance analysis, and it looks like it scales up all the way. But as customers get to this, I'm sure we will get deep into some performance analysis and see just how far we can go with this. Our usual sort of rules of thumb are that you should only have a worker thread tied to a CPU. If you're an RDMA configuration, you don't want to end up with 2 worker threads being shared on a CPU, on a logical CPU. That can lead to slower performance, a lot of context switching, cache clearing, and other bits and pieces, which is why we have the sort of mapping. And usually we recommend leaving a few CPUs free. That generally leads to better system performance. When it comes to TCP/IP, pureScale, then our recommendation is still to use basically 8 times the number of logical CPUs. So bumping up to 96 is a significant step forward. Generally, we find that systems will bottleneck on the ability to pass packets around the network, though, before they bottleneck on the ability to use the CPUs in the system. Moving on, so we have better performing page cleaners in busy clusters. In pureScale, sort of our original design basically had 1 cast out class with a single latch, which was fine when we started out with small systems. But as we've seen customers grow to bigger and bigger systems and have more and more members, it became clear that this cast out latch was becoming a bottleneck. In 11.1, we had a number of customers who were running with registry variable set to sort of change this behavior. And over time, we've built lots of confidence in this system. And in 11.5, we've made this the default. So we've moved from 1 latch, which could get really quite hot, to 1,024 latches now. And that has really quite significant performance improvements for really intensive OLTP workloads over many members. We've seen 15–20% improvements on some systems. So what's coming next? So there's no shortage of interest in pureScale in the cloud. We're not quite there yet. And yes, you can set up a test system in the cloud. You can bring your own license. We've seen a lot of challenges in terms of getting these systems to perform. We've seen Networking, particularly for a lot of cloud providers, is variable. Sometimes it's good, sometimes it's bad. And DB2 pureScale as a configuration is very latency sensitive. So we're always looking at ways we can improve the design of pureScale, improve the capabilities of data centers to make sure that we can make the best use of their facilities and try and limit the sort of costs of network latency. We continue to look at the things we can do for our geographically dispersed pureScale clusters. We've put in some basic infrastructure to allow us to sort of identify some key attributes about where the various hosts are located. Today, we don't have any knowledge of where they're sited. We've put that in, and we will be building on that through the 11.5 series. Another area we're investigating is the areas where DBAs and installers come in and they have to manually configure various parts of the system for pureScale. And over the years, we've seen a number of very quirky problems, particularly around our friend, etc. hosts. We have recommendations in our documentation for how this file should be laid out. Please follow them if you're setting up a cluster. But we want to put validation in so that we can catch configurations which may on the surface work, but lead to sort of strange behavior within the pureScale cluster. So it's very important that the ordering of IP address, FQDN, and short name is consistent throughout not only the host, but across all the hosts. They can avoid having some very strange problems with different parts of the pureScale infrastructure, seeing different systems. Another area which has been troublesome over time is the dat.conf. That's key for configuring how the RDMA adapters are registered for pureScale. And we're always looking to see where else we can sort of step in and make sure that things are properly configured. We're always looking at performance. So I've already talked about load and load with range partition tables. We hope we can get some steps forward there. That'll probably happen sometime in the next year. Another area which is an interesting technical challenge is hang detection for a stuck member. We're investigating a number of different approaches to how can you tell that a member is actually stuck, that it is actually genuinely hung and not just sort of in deadlock or just not handling connections at the moment for other reasons. So that turns out to be an interesting technical challenge, and we've got a number of people looking at how best to tackle that one. We'll also look and see whether that sort of hang detection can be used more widely, HADR systems. That's another area of interest. Yeah, so we continue to expand pureScale to more new platforms, new hardware. We're trying to make it a simpler system, try and sort of make sure we manage the complexity of having a number of different software components, and generally make life easier. We have an opportunity for you to take a look and see what we're planning. The IBM Analytics Roadmap is available. I think it's protected by an IBM ID, but anyone can go and get themselves registered with an IBM ID and go and have a look. That lays out our plans, the things we're working on. I think it lays out sort of the first and second half of 2020 at the moment. And that's true for all of the sort of DB2 family, not just DB2 pureScale. And another area where we're looking for dialogue and looking for people to come forward with their experiences is what used to be RFEs and are now known as ideas. They can be, again, proposed on the AHA platform. That's proved to be fruitful for lots of reasons. We've seen lots of great ideas coming from customers. We can't get to them as fast as we want to. We've been growing the team over the last few years. pureScale is growing customers, and we are growing our technical team. Yes, the ideas also sort of help point us in the direction we need to go to make sure that we're meeting most people's needs. So, and they don't have to be big ideas. Sometimes simple ideas can be hugely beneficial. So we welcome all the input we can get. And that is my presentation for today. It seems to have got to the top of the hour. There we go.
Good for you. Just perfect timing there. Let everybody get to lunch on time. Nobody ever seems to mind going to lunch. And I found out that I'm an idiot and I had forgotten how to run polls, but I'll fix that now. And we'll at least ask our final poll. But first, I need to take control back from you, and I'll do that first. Put a nice, good, succinct. There's a lot to talk about on pureScale. It's a very, very big thing, and I'm looking at the wrong thing. You can see I was doing some homework there. I've got to, believe it or not, I have to teach a class on DB2 on the iSeries platform soon. That's a real, that's an adventure. It's so much fun. What a great platform that is. All right, now that I've got you back here, let's quickly put up our last poll, which I did have set up. I just wasn't really, I guess I got skittish this morning. But our final poll is always, did you learn anything today? Oh, I need to hit this launch button. I told you I was having a day. We're getting snow here.
Yes, it's coming down outside.
Yeah.
Yep.
And we've had enough people vote on that, so I'm going to close that off and share the result with our audience. And so 100% of our audience learned something again today.
Oh, that's always good news.
That is
I was a bit worried coming up after Dale last time, so it's good to see.
It's a lofty goal, and if you fall short, well, you've fallen short because you can't really get above 100%. So, but we've been lucky lately that we've been able to hit that target, and we've done it again today. That's a credit to your great presentation. So with that, I'm going to move on and say today our show once again was sponsored by DBI, our founding sponsor. We thank them for the use of the meeting room and the ability to record it and share this information with you. So with that, I'm going to turn everybody back to yourselves and cue the music. Say thanks once again. We'll see you in 2 weeks for our next DB2 on Z show. Have a great weekend and all the best. Bye-bye. Thanks so much,
Bye-bye. No, thank you.